Assalamualaikum dan selamat sejahtera. This is my first video, your first lesson for this year, chapter 1, part 1, from 5. Okay, let me introduce myself first. My name is Puan Aini Nordiana. I am your maths teacher. Okay, what are you going to learn in this chapter? So, our first chapter is variation. We have 3 subtopics for this chapter: direct variation, inverse variation, and combined variation. For this video, I will focus on direct variation. Okay, our learning standard for today's lesson: explain the meaning of direct variation. What is the meaning of direct variation? Direct variation explains the relation between two variables, such that when variable y increases, then variable x also increases at the same rate and vice versa. This relation can be written as y varies directly as x. Okay. We can write as y varies directly as x. Okay, this is the symbol of direct varies directly. Okay, let's look at example 1. The total wage of a part-time worker as a promoter varies directly as the number of hours he works. State the change on the total wage if the number of working hours is double. So, of course, when the number working hours is double, then the total wage is also double. The total wage is the number of working hours decreased by 40%. So the total wage also decreases by 40%. If the number of working hours is half, then the number of working hours also half. Okay, do your homework, self-practice 1.1a. Let's move on to our learning standard. This is our second learning standard. Determine the relation between two variables for a direct variation. So, what is the relation between two variables for a direct variation? Okay, in direct variation, quantity y is said to be varies directly as x if and only if y over x is constant. Constant means equal value, known as the constant of proportionality k. This is the symbol of constant. Okay, relation between the value of k and the concept of proportion y1, x1, y2, x2, when you divide, it will give the same value. When you draw a graph, you will get the straight line. So when y varies directly as x, then the relation is written as y varies directly as x. From the relation, the value of constant of proportionality k can be determined. That is, k equals to y over x. Okay, for a direct variation, y varies directly as x can be written as y varies directly. This is the symbol for varies directly. And this is the equation. Y equals to kx, where k is the constant. Okay, in general, for a direct variation, y varies directly as x to the power of n can be written as y varies directly to x to the power of n. And this is the equation form. Just add k here. Okay, let's look at example 2. A toy car moves from a state of rest. The distance traveled by the toy car y changes with time t as shown in the table below. So look at this table. Determine whether y varies directly. So how to determine this? We have to calculate the constant. So this is the value of t and y as in the table. Then find the value of y over t and y over t squared. If the value of y over t is equal, then we can conclude that y varies directly as t because the value of y over t is constant. Hence, we can say that y varies directly as t. As you can see, when you divide y over t squared, the value is different. So, y does not vary directly as t squared because y over t squared is not a constant. So, we can also draw a table for this question. This question, y does not vary directly as x because the straight line does not pass through the origin. Okay, this question, when we draw a graph, the graph passing through at the origin, so we can say that y varies directly as x squared. Okay, example 4. It is given m equals to 0.8 and n equals to 0.125. Express m in terms of n if m varies directly as n, m varies directly as the cube root of n. So this is the step. The first step, just write m varies directly as n. Then write the relation in the form of equation m equals to kn. Then substitute the value of m and n from the question. Then you will get the k. Hence, substitute the value of k into the equation m equals to 6.4 n. Do the same thing for question B. First step, write m varies directly as cube root n. Then write the relation in the form of equation. Substitute the value of m and n. Then you get the k. Hence, m equals to 1 over 6 cube root of n. Okay, look at example 5. The extension of a spring XCM varies directly as the mass of the load Wg hanging on the string. It is given the extension of a spring is 3 cm when a load of 200 grams is hung on the string. Express x in terms of W. The same step. First, write x varies directly as W. Then write the relation in the form of equation. Substitute the value and then you get the value of k. Hence, substitute the value of k into the formula. Example 6. It is given y varies directly as x. Also given the value of y and x. Calculate the value of y when x equals to 5 and value of x when y equals to 0.825. For this question, first you have to calculate the value of k first. So use the same step just now. First write y varies directly as x. Then write in the form of equation. Substitute the value of y and x. Then get k. So this is the formula. So when you want to calculate the value of y, just substitute the value of x into the formula and then you'll get the value of y. Same goes to question B. When y equals to 0.875, substitute the value from this equation and then you'll get the value of x. So let's move on to example 7. The area L cm square of a semicircle varies directly as the square of its diameter d cm. It is given that the area of the semicircle is 3.08 cm square when the diameter is 2.8. Calculate the value of d when L equals to 19.25. Actually, this is the same question from example 6, but this is more to the more on problem solving. So first, as I mentioned just now, you must find the value of k. So this is the value of k. First step, you write L varies directly as d square. Then you write in the equation form, substitute the value of L and d. Then get the k. Then this is the formula. Then you substitute the value of L because you want to find the value of D. So here the answer for D. So example 8. The period of oscillation a second for a simple pendulum varies directly as the square root of the length of a string PCM. It is given that 9 cm string of a simple pendulum oscillate for 1.2 seconds. Calculate the period of oscillation in seconds if the length of the string is 25 cm. So, same question from our previous example. Do the same thing, find the k and substitute the value. Okay. Always remember the first step to write the equation in the equation form and then calculate the value of k and then substitute the value. So you will get the answer. So for today's homework, self-practice 1.B. So you have two homework for this week, 1.1A and 1.1B. Okay, that's all for this video. Next video we'll discuss about the homework. Hopefully you will complete the homework so that we can discuss the answer. Okay, that's all for now. See you in the next video.